application using liquid max bullet valve. To show you this, we have prepared this material here. So first of all, we are using water, and the water is pressurized. We have the water tank here. The water is pressurized at 3 bar. The water is connected to the inlet of the liquid valve. We have a nozzle here, and what we're going to do is that we will project water into the jar here. We have this microgram scale, and because we are working with water, we know that 1 milligram is equivalent to 1 micro-litre. We have here the pulse generator, which we are going to use to generate very small activation signal of the valve. We work here, for example, with a 20 milliseconds period and a duty cycle of 50%. So it means that the valve will be energized for 10 milliseconds. We want to show, first of all, the precision of the dosing, the repeatability from one cycle to the next cycle of the dosing. So let's start, for instance, with this 10 milliseconds on time energization of the valve. We are going to project water into the pot and see the weight of water that we get into the pot. So we can see that with 10 milliseconds energization, we have about 28 microliters of liquids which are inside of the pot. Now what I'm going to do, I will energize the valve again for the exact same time and see what happens. And we can see that by energizing the valve a second time, the exact same time, we have the double amount of liquid inside of the pot. What we are going to do now is to increase the number of energization of this 10 milliseconds energization. We saw that 10 milliseconds energization gave us 30 microliters of water, and we are going to make 10 cycles in a row in order to have 300 or 280 microliters of water. So I will increase the number of cycles to 10, and now let's see what happens. So we have 285 microliters of water. I will start again this 10 cycle and see what happens. And we have 568. So we can see that we are extremely repeatable. Okay. Now we will increase again the number of cycles to 20 cycles directly. And let's see what happens. We start the scale again to 0, and let's go. So we have directly 565 or 560 microliters of water in the jar.